You know, our modern world is built on so many hidden heroes. Technology's working away behind the scenes.
Absolutely. Things we rely on every day without even thinking about them.
Exactly. And today, we're pulling back the curtain on one you might never have heard of,
Hmm.
the insulated gate bipolar transistor, or IGBT for
It's
short.
IGBT, yeah. Definitely not a household name.
Not at all. But trust me, without this, well, this pretty unassuming component, your electric car, it would be drastically less efficient.
Oh, for sure. And things like renewable energy, solar, wind, they wouldn't be powering nearly as many homes either.
It's like this invisible hand making high power manageable, right?
Yeah.
We've gathered some great sources explaining what it is, how it works, the key applications.
Hmm.
So our mission for this deep dive is pretty straightforward. Let's quickly get a handle on why this power semiconductor device matters so much. Okay, let's unpack this.
What's truly fascinating here, I think, is how a device really designed for raw power also delivers this incredible precision.
Ah, okay. Power and precision.
Exactly. And that makes it a cornerstone for energy efficiency in, well, almost everything, from your car to the wider smart grid. It's not just about flicking a switch on or off.
Right.
It's about controlling that power with like surgical accuracy.
Right.
Our sources really drive home how significant that capability is.
So, okay, the IGBT. For someone who's just hearing this acronym now,
Hmm.
what exactly is it? What's its basic job?
Right. So IGBT, insulated gate bipolar transistor, at its heart, it's a power semiconductor device.
Okay.
But don't just think of it as a simple on-off switch. It's more like a very finely tuned power valve.
A valve. Okay, I like that analogy.
Yeah, one that can open and close incredibly fast, handling huge amounts of energy, with real precision. Its main role is in modern electronic circuits, especially where you're dealing with both high voltage and high current.
High voltage and high current. So the tough stuff.
Exactly. This isn't just another tiny component on a circuit board. It's engineered for the big leagues of power control.
Got it. So a powerful switch, a transistor, and insulated gate implies it's easy to control, right? That's the insulated gate part.
That's a key part of it, yes. The insulated gate makes it very easy to drive, to turn on and off.
Okay. Sounds like it fills a really specific, really powerful need then. Our sources kept highlighting this idea that it combines the best of two other devices. What's that about? What's the ingenious blend happening there?
Ah, yes, that's really the core of its innovation. It truly is an ingenious blend. That hybrid nature is precisely what makes the IGBT so powerful and versatile.
Okay.
It's like you're getting the best abilities from two different, let's call them electrical engineering superheroes.
Yeah.
So from one side, the MOSFET side, it gets this ability to be controlled with almost no effort.
Like you barely have to nudge it.
Pretty much. Imagine flipping a giant power switch with just a tiny signal like a whisper.
Mm-hmm.
That ease of control, that's critical in complex power systems.
Right.
And then from the other side, the BJT side, it gets incredible efficiency when it's on. It means very little energy is wasted as heat, even when handling lots of current.
Ah, okay. So
Yeah.
easy to turn on and doesn't waste power when it is on.
Exactly. This dual capability, combining that high input impedance of a MOSFET with the low on-state voltage drop of a BJT, that's what gives it such an edge in high-power applications. It's the best of both worlds, truly.
That is incredibly effective. Easy to control, super efficient with lots of power. It almost sounds too good to be true. Can you give us a simplified picture of how it actually works, like mechanically speaking,
Yeah.
once you give it that little whisper of controlled voltage?
Absolutely. You can think of it like a two-part dance. It's a good way to picture it.
Okay.
First, you apply that small voltage to its gate. That's the whisper we mentioned,
Mhm.
similar to how you trigger a MOSFET.
Right.
That voltage basically opens the pathway. It creates the condition for current to flow.
Got it.
You know.
Opens the door.
Exactly. Then second, once that pathway is open, it allows a very large current to flow between its collector and emitter. And this part is more like how a BJT conducts heavy current.
Ah, so the control is like a MOSFET, but the muzzle, the current handling, is like a BJT.
You've got it. The combined effect means it can efficiently switch huge amounts of power on and off, and crucially, it can do it at very high speeds. It's all about channeling significant power with fine control.
That's kind of precise high-speed control. Wow, that sounds absolutely essential for so many modern systems we rely on.
It really is.
So I'm guessing they're pretty much everywhere then, even if we don't realize it. Where are we actually, bumping into these devices in our daily lives?
Oh, you'd be surprised how often you interact with systems using them, especially now with the shift towards more electric power and efficiency.
Okay, like where?
Well, IGBTs are crucial components in things like inverters, the boxes that convert power from one form to another.
Right, DC to AC or
hmm
changing frequency.